So in this video, we're going to be looking at capacitors in series and parallel calculations. We'll consider two questions in series calculation, and then we'll consider two questions in parallel calculations, all in this video. So we're solving a total of 4 problems in this video. Now let's start with the very first question. It says two capacitors 8 microfarad and 16 microfarad are connected in series. If the total voltage across the combination is 24 volts, question says calculate the equivalent capacitance, and the B part says the voltage across each capacitor. Okay, so we have our circuit diagram illustrating the question. Now, when capacitors are arranged in series, it means that the same charge flows through them, right? First of all, before we start solving this problem, let's lay out some foundations. So the formula for capacitor can be defined by formula as simply charge all over potential difference, which is V. That's the formula. So from this circuit diagram, we'll have two capacitors, 8 microfarad and 16 microfarad. Capacitors are said to be in series when the same charge flows through them. So what comes out from this source is the charge, right? This charge flows in this direction, flows in these directions. So we have the charge flowing in this direction, entering this capacitor, then flows out of this capacitor, and then enters this capacitor and also flows out. So it is still the same charge that flows through each of these capacitor, which is why they are said to be in series. So when the same charge flows through them, they are simply said to be in series. Now, to find the equivalent capacitance, that's to answer the very first question. When capacitors are arranged in series, to find the equivalent capacitance, you take the reciprocal of the individual capacitors. So with that being said, you're going to have 1 all over C equivalent, where C equivalent is the equivalent capacitor. That becomes 1 all over C1 plus 1 all over C2, depending on the total number of capacitors that you have. So in this case, we just have 2 capacitors, so we end the formula here. Now this simply implies that 1 all over C equivalent is going to be equal to, so 1 all over, the first capacitor there is 8 microfarad, okay, 8 microfarad plus 1 all over, the second capacitor there is 16 microfarad. So we have 1 all over C equivalent to now be equal to, the LCM between those two capacitors, between 8 and 16, is simply obviously 16 microfarad. So 16 microfarad, so 16 microfarads goes into 8 microfarad. That gives us 2 times 1 is actually 2, plus 16 microfarad goes into 16, that's 1 times 1 gives us 1. So this simply implies 1 all over C equivalent becomes now 2 plus 1 there is 3 all over 16 microfarad, right? So in order to find the equivalent capacitance, which is C equivalent, you simply invert, take C up, bring 1 down, then you do the same thing on the right hand side, take 16 up, bring 3 down. So this simply implies C equivalent becomes what? 16 microfarad divided by 3. So with this, we have answered the very first question of determining the equivalent capacitance. So let's obtain 16 divided by 3. So 16 divided by 3 simply gives us 5.33 microfarad. So the equivalent capacitance is simply 5.33 microfarads. That's the first question answered. Now the second question, the B part, says we should calculate the voltage across each capacitor. Now in order to do this, the first thing, you observe the formula of capacitor like I stated earlier. It is simply charge all over potential difference. Now we know the equivalent capacitance, we know the equivalent voltage source, which is given in the question as 24 volts, but what we don't know is the equivalent charge. So in order to be able to answer the second part, we need to find the equivalent charge first. Then from that relationship, we can now find the individual voltage across each of the capacitance. So we need to make charge subject of the formula from here, right? So from that formula, you recall we said capacitor is simply what? Charge all over potential difference. So we simply make charge subject, that becomes what? Capacitor. In this case, it becomes the equivalent capacitor multiplied by the word source potential difference. So this is going to be equal to, equivalent capacitor give us 5.33 microfarad multiplied by the source voltage was given in the equation as 24 volts. Okay, so this simply implies that the equivalent charge or the charge across the circuit is going to be equal to 128 volts. Sorry, 124 coulombs, please. The unit of charge is the coulombs. So this is now the equivalent charge or the charge across the capacitor. But once again, recall, charge is what? The product of capacitor times voltage, and since the charge is even the same on each of these capacitors, then we can now easily find what the potential difference, so that across each capacitor. So this simply means that charge is going to be equal to C1 V1. So with this we can find the potential difference across what? The capacitor C1. So that therefore this simply means that V1 is going to be equal to what? That becomes the total charge all over capacitor C1. So and also V2 potential difference across the second capacitor. V2 becomes also total charge divided by what? The second capacitor. So let's start with the first. This implies V1 is going to be equal to total charge. We had 128 coulombs, so 128 coulombs divided by the initial or the first capacitor, please. The very first capacitor is 8 microfarad, so divide by 8 microfarad, divide by 8 microfarad. So this simply implies that the first voltage or the voltage across the 8 microfarad capacitor becomes 128 divided by 8, and that simply gives us 16 volts. So this simply means that the voltage across the 8 microfarad capacitor is actually 16 volts. So using the same formula and the same approach, we find the voltage across the second capacitor. Remember, V2 is equal to the equivalent charge or total charge, which is 128 coulombs. 128 coulombs divided by the second capacitor, right? Second capacitor is simply 16 microfarad. So this simply implies that the voltage across the 16 microfarad capacitor, 128 divided by 16, will simply give us 8 volts. So which means that for the 16 microfarad capacitor, the voltage across it is 8 volts, and for the 8 microfarad capacitor, the voltage across it is actually 16 volts. And if you sum these two, you're going to have the total voltage. Remember, total voltage becomes V1 plus V2, and we had 18 plus 16. This is actually what? 24 volts, which is the total voltage across the circuit. So that's it for the first question. Let's now consider the second question. Alright, so the second question says, if a 5 microfarad and a 10 microfarad capacitor are connected in series, what is the charge stored on each capacitor when a 12 volt battery is connected across the system? Okay, so in this case that you have a 12 volt battery connected, the capacitors are 5 and 10 microfarad respectively. Now once again, in order to be able to solve this, you have to first of all find the equivalent capacitor, right? So that's our first task. Remember, since we have two capacitors, so 1 all over C equivalent. Whenever they are in series, you take the reciprocal of each of them. That becomes 1 all over 5 microfarad plus 1 all over 10 microfarad. Okay, so this simply implies that 1 all over C equivalent becomes The LCM there is obviously 10 microfarad. So 10 microfarad goes into 5 microfarad. That simply gives us 2. 2 times 1 gives us 2, plus again 10 microfarads divides 10 microfarads, that's 1. 1 times 1 gives us 1. So this simply implies that 1 all over C equivalent is actually what? 2 plus 1 is 3 all over 10 microfarad. Now, in order to find your equivalent capacitor, remember I said you have to first of all just interchange the position. Take C equivalent to the top, bring down 1, then do the same thing on the right. Take 10 microfarad up, then you bring down 2. Okay. So when you do that invert, you're going to be having C equivalent. So this simply implies that C equivalent is now going to be equal to 10 microfarads divided by 3. So let's obtain this result. The equivalent capacitance is going to be equal to 10 divided by 3. That gives us 3.33 microfarads. So the equivalent capacitor is approximately 3.33 microfarad. Now, having found this, the next thing to do is to find the equivalent charge. Remember from definition of capacitors in series, I said capacitors are said to be in series when the same charge flows through them. So the question is asking us to find the charge across each of the capacitors. So if we're able to find the equivalent charge, that charge becomes the same because the charge across capacitors in series are what? The same. Okay. So now you recall your capacitor equation. Capacitor is simply charge all over potential difference. So you simply make charge subject, that becomes capacitor, and this becomes the equivalent capacitor multiplied by the source potential difference. So this is going to be equal to equivalent capacitor we obtained 3.33 microfarad multiplied by the voltage source given there is 12. So this simply means that the charge across that circuit or across the two capacitors is going to now be equal to 3.33 multiplied by 12, and we have this to be approximately 40 coulombs. So the charge there is simply 40 coulombs. Now, since a capacitor in series have the same charge, this simply means that the charge across the first capacitor Q1 is equal to 40 coulombs and Q2 is also equal to 40 coulombs. So the two charges are what? The same. Now the next two questions will be considering parallel cases. So let's get to parallel calculation. Alright, so let's consider this other question. It says 3 capacitors, 2 microfarad, 4 microfarad and 6 microfarad are connected in parallel. Question says find A, the equivalent capacitance, B, the total charge stored when connected to a 12-volt battery. So when they are connected in parallel, you have something like this. Now by definition, a capacitor is said to be connected in parallel when they are arranged in such a way that the same potential difference flows through them but different charges, right? So the charge flowing through each of these capacitors are different, but the potential difference are what? The same. Now let's start with the first part to find the equivalent capacitance. So to find equivalent capacitance for capacitors in series, all you need to do is simply what? Add to the total number of capacitors involved. In this case, we have 3 capacitors, so it becomes C1 plus C2 plus C3. Okay, so this is actually going to be equal to 2 plus 4 plus 6. So this simply implies that the equivalent capacitor becomes what? 12 microfarad. This becomes the equivalent capacitor for this system. So that's the first question answered. Now the next question says find the total charge stored when a 12-volt battery is connected. Okay, so to do this, you recall your capacitor equation. Recall that we said capacitor is simply charge all over potential difference. So this simply means total charge becomes capacitor times potential difference. Now This capacitor here is equivalent, the equivalent capacitor calculated earlier, which is 12 microfarads. So total charge becomes 12 microfarad multiplied by the potential difference, which is 12 as well. So this simply implies that the total charge acting on that system is actually 12 by 12, which is 144 coulombs. So this is the total charge on the circuit. Now let's pick the second and the final question under parallel condition. Alright, so let's consider the final question for this session. The question says a 20 microfarad capacitor and a 30 microfarad capacitor are connected in parallel. If a total charge of 300 microcoulombs is stored, find the voltage across each capacitor. So once again, the first thing we'll do is to find the equivalent capacitor for this given situation. So since it is parallel, remember, equivalent capacitor simply means you add total capacitors together. So C equivalent is going to be equal to 20 plus 30, and that simply gives us 50 microfarads. So this is the equivalent capacitor. Now, remember when I defined capacitors in parallel earlier, I said capacitors are arranged in parallel such that the same voltage flows through them. So when they are in parallel, the same voltage is flowing through them, but when they are in series, the same charge is flowing through them. But not forgetting, we are giving total charge. Okay, we are giving total charge, which is Q, was given to us at 300 microcoulombs. So this is our total charge. Now all we need to do is recall from the equation of capacitor. Recall, we said capacitor is simply what? Charge per unit potential difference. Now we need to find the voltage. Voltage is going to be equal to what? Charge all over capacitor, and this becomes the equivalent capacitor. So total charge divided by equivalent capacitor, and this is going to be equal to, total charge is simply 300 microcoulombs divided by equivalent capacitor is 50 microfarad. So micro cancels out. You have 300 divided by 50. This simply implies that the potential difference is going to be equal to what? 6 volts. Alright, so remember that when capacitors are arranged in parallel, the same potential difference flows through them. So this simply implies that potential difference across the first capacitor V1 is equal to the potential difference across the second capacitor V2, and that is equal to what? 6 volts. And that is simply the answer. Alright guys, so that's it for this session. I'm sure you find this video very interesting. Please do well to like, comment nicely, share to your friends, and if you're new to the channel, do well to hit the subscribe button and turn on your notification bell so you don't miss out on our subsequent videos when it drops. I will see you in the next video. Thanks.